section 2.8 is on inverse functions. And the definition of a function for every x, there is what? Finish the sentence. For every x, there is
Y.
Well, there's always y. So what? So don't be bashful. Do I look bashful? Don't you be bashful. Be like me. Don't be bashful. So who said that? What'd you say?
I said 1Y.
1y. Exactly 1y, right? For every x, there is exactly 1y. So given the graph of an equation, right, we know it meets the definition of a function. By the vertical line test. Does anybody know what the definition of a one-to-one function is? You just switch the x and y in this sentence. For every y, there is exactly 1x. And so given the graph of a function, how we determine whether it's one-to-one, what test do we have? You probably learned it in high school. Did you ever hear the horizontal line test? We have the horizontal line test. Okay? So you studied functions and one-to-one functions in high school just by virtue of the fact you know what a vertical line test is and what a horizontal line test is. So let's look at the graphs of a couple of functions that you're familiar with. The first one we'll look at is f of x equals x squared. And the graph of f of x equals x squared is a what? Parabola, right? Goes through the origin. And so we call this the squaring function. Now I'm going to graph f of x equals x cubed. That's another one you should be familiar with. This is from section 2.2. Remember, there were 5 functions in section 2.2 I said you should be familiar with. You remember what the graph of x cubed looks like. We call it the cubing function. Do you remember what it looks like? It what? Yeah. I say it snakes through the origin. Right? That's the cubing function. Okay? So, in describing both of these, right, I use function notation, right? I call them a function. And you can see from the graphs, right, these are the graphs of 2 functions, right? They both pass the vertical line test. Is the squaring function a one-to-one function? No, it fails the horizontal line test. If I draw the horizontal line here, it intersects the graph in two locations. It means for this one value of y, where the line crosses the y-axis, there are 1, 2 values of x. Okay. So we got 2 points with the same value of y, but they're different x coordinates, right? So 2 values of x. So this guy fails the horizontal line test. That's what HLT short for, horizontal line test. So this is not a one-to-one function. What about the cubing function? Is it a one-to-one function? Yeah, right? No matter where I draw the horizontal line, it intersects the graph in only one location. So it's a one-to-one function, right? It passes the horizontal line test. So it's a one-to-one function. Okay. And so in order for a function to pass a one-to-one function, they basically got to be going uphill from left to right or downhill from left to right. If they go up and down, there's going to be some place where it doesn't pass the horizontal line. Okay. All right. So this section again is on inverse functions. And so only one-to-one functions have an inverse function. So that's why we're interested in one-to-one functions. Okay. So you know, this is f of x, this is function notation, right? X is the input, little f is the name, right, of the function. Okay. If f of x is a one-to-one function, it has an inverse, and we denote its inverse function with f with a -1 in the superscript. So this is inverse function notation. Okay. Again, x is the input, and f inverse, f with a -1 in superscript, right, is the name. So as this is read f of x, this is read f inverse of x. Okay. The -1 is not an exponent. Okay. So you know, if in algebra, if I write 2 to the -1 power, right, put a -1 on the superscript, right, that means 1 over, right, the reciprocal of 2, 1 over 2 to the first power, which is 1/2. If I write x to the -1, same thing, 1 over x to the first, which is 1 over x. This -1 superscript does not mean that. It's just fancy mathematical notation to represent an inverse function. Okay, we put the -1 on the superscript of the name of the function to indicate it's the inverse function for f of x. Okay. All right. So how do inverse functions and one-to-one functions work? Okay. So I'm just making this up. Off the top of my head. Don't ask me where I got the numbers. I'm just making it up. If I have f of 2 is equal to 5, okay, then, and f of x is a one-to-one function, then its inverse, f inverse of 5, right, its inverse function evaluated at 5 is equal to 2. So one-to-one functions and their inverses go in opposite directions. The input to the one-to-one function is the output to the inverse function, okay? And the output to the one-to-one function is the input to the inverse function, okay? If you know f of 2 is equal to 5, then you automatically know that f inverse of 5 is equal to 2, okay? If you know the value of one function, right, at one value of x, then you know the value of the other function, okay? All right. The graph of f inverse of x is symmetric to the graph. I don't want to use the word symmetric. I take that back. Okay. The graph of f inverse of x, okay, is a reflection of the graph of f of x about the line y equals x. Okay. And so the line y equals x is a diagonal line that makes a 45-degree angle with the x-axis. So we'll demonstrate this. Okay. So I'm going to draw a coordinate plane. X-axis, y-axis. Okay. Here's the origin. So x equals 1, x equals 2, x equals 3, x equals 4, minus 1, minus 2, minus 3, minus 4. So that's the x-axis. Then y equals 1, y equals 2, y equals 3, y equals 4, y equals minus 1, minus 2, minus 3, minus 4. Okay. Now the line y equals x, it has a slope of 1, right? It goes right to the origin, and it bisects the first quadrant and the third quadrant, right? Makes a 45-degree angle with the x-axis. So do the best you can to draw, right, that 45-degree angle. So you see that dashed slanted line? That's the line y equals x. Okay. Slope of 1 goes through the origin. Okay. Now I'm going to graph my f of x. Okay. Now there's no algebraic, I don't have an algebraic expression for f of x in terms of x. I'm just going to plot points and connect the dots. So one point that's on the curve of f of x is the point 2, 4. Another point, it crosses the y-axis at y equals 1, right? So that's the y-intercept. And then another point on the graph is minus 4, minus 2. Okay. Kind of hard to draw when you're 6 inches from the board. So now I'm going to play connect the dots. okay? The best of my ability. And so it goes down and to the left forever and up and to the right forever. Okay? So this is the graph of my one-to-one function f of x, okay? So again, this is the point 2, 4. This is the point 0, 1, right? The y-intercept. And this is the point minus 4, 2. Minus 4, minus 2, excuse me. Okay. And you can see that's a one-to-one function, right? Passes the horizontal line test, right? Vertical and horizontal line test. Okay. Now, to graph the inverse function, you know what? We got to flip it over this diagonal line, right? To get it the graph of the inverse function. You maybe remember from high school how you would do that. All you gotta do is take these points on f of x and switch the x and y coordinates, and then plot those points, and you have the graph of the inverse function. Okay? So we're gonna switch SWITCH. We're gonna switch x and y coordinates. And plot those points, okay? So we have, for f of x, we have the ordered pair xy. For the inverse function, we have the ordered pair yx, okay? Y becomes the first coordinate, x becomes the second coordinate, okay? So here we have the point 2, 4. So when I switch the x and y coordinates, I had the point 4, 2. So here's x equals 4, and then I go up 2. And now I have the point 4, 2. So 2, 4, the point 2, 4 becomes the point 4, 2, right? All I do is switch the x and y coordinates. Now here we have the y-intercept 0, 1. So when I switch the x and y, I have the point 1, 0, which is an x-intercept on the inverse function. And then here I have the point minus 4, minus 2. So when I switch x and y, I have the point minus 2, minus 4. So here's minus 2, and then I go down 4 to right here. Okay. So this is the point 1, 0, and then this is the point minus 2, minus 4. Right, so now the points 4, 2, 1, 0, and minus 2, minus 4. Okay. And now we play connect the dots to get the graph of the inverse function. Okay. So the graph of the inverse, and again, you know, we're doing this we're freehanding. So, you know, just do the best you can. Okay. And that's not a perfect reflection, but again, we're doing it by hand. We don't have a grid, okay? If we had a grid, it would be a lot easier, right? Plotting these points and playing connect the dots. But this is then the graph of f inverse of x. Okay. So given the graph of f of x or f inverse, you can get the other graph just by switching the x and y coordinates. And that all comes back to this example, right? The x coordinate for f of x is the y coordinate for f inverse, and the y coordinate for f of x is the x coordinate for the inverse. Okay. All right. Any questions, ladies and gentlemen? on the graph of a one-to-one function and its inverse. Okay. All right. So there are a couple of important properties, right? So remember, what goes into f of x is called the domain, and what comes out is called the range, right? Well, in this case, what comes out of f of x goes into f inverse, so the range of f of x is the domain of the inverse function. And what goes into f of x comes out of the inverse. So what goes into f of x is the domain, and so what comes out of the inverse, right, is the range of f inverse. So the domain of f of x is equal to the range of the inverse function, and the range of f of x is equal to the domain of the inverse, right, because they're switched. What goes in is called the domain, what comes out is called the range. So we have these two important properties. The range of the inverse function, f inverse of x, equals the domain of f of x. Okay? The range of f inverse of x equals the domain of f of x. Right? So the range of the inverse function equals the domain of the one-to-one function. And then it's also true the range of the one-to-one function f of x equals the domain of f inverse of x. That is an important property. These are two important properties because we know how to find the domain of functions, right? That was exam 2 material. Finding the range is often more difficult. So with this relationship, if you need to know the range of the inverse function, you just get it from the domain of f of x, the one-to-one function. Okay? And if you need the range of f of x, you just get it from the domain of f inverse. Okay? Which we're now going to demonstrate by a couple of examples. Okay? All right. Any questions thus far? Okay. All right, so there are 4 steps that you use every time in finding the inverse of a one-to-one function. Okay. Step number 1, replace f of x with y, right? You know, y values and function values are the same, right? We've been saying for a while now, right? Y equals f of x, right? So y is a function of x. Y values and function values are the same, okay? So given f of x equals something, right, we replace f of x with y. Step number 2 is we then switch x and y from that equation. Okay. Step number 3, we then solve for the variable y. And then step number 4, we replace y with inverse function notation. Now, keep in mind, right, in math, we like to use f for the name of the function a lot, right? But this could be g of x or h of x, right? We could be using other letters of the alphabet. Okay. So it's the same 4 steps every time in finding the inverse of a one-to-one function. And it's important that you know these 4 steps because we're going to be working with them for the rest of the semester, not just in this section. Math is cumulative. So in this exercise, okay, we're going to find the inverse function for f of x equal to 3x over x minus 4, okay? And state the domain and range for f of x and f inverse of x. And I guess I should add in interval notation. Okay. All right. So finding the inverse function for f of x, step number 1, replace f of x with y. So we have y is equal to 3x over x minus 4. Step number 2, switch x and y. So replace y with x and x with y. Okay. Step number 3, solve for y. Okay. So just to write it out, right, this is replace f of x with y, switch x and y, and now we're going to do step 3, solve for y. Okay. So we got a rational function. We got 2 y's on the right hand side, right? One numerator, one denominator. And so we got to go from 2 y's down to 1 with the y isolated on the left hand side. Okay. And sometimes there's more than one way to solve for y. But there's, when you're dealing with rational functions like this, there's one way that seems faster and easier than the other. Okay. So the first step we're going to do is clear the fraction on the right-hand side by multiplying both sides by the denominator. Okay. So remember, this is 3y divided by y minus 4, and what undoes division? Multiplication. Okay. So we're going to multiply the left-hand side by y minus 4, and you got to put it in parentheses. I know college students have a reluctance to use parentheses, but we're multiplying both sides by the entire denominator, not just y. Okay? So we have x, so x gets multiplied by y minus 4. Okay? And then we multiply the right-hand side by y minus 4. So multiplication by y minus 4 undoes the division by y minus 4. That's why we did this. Okay, that cancels. And now on the left-hand side, okay, I need to distribute the x inside the parentheses because we want to get down to 1y. Okay, and this need that in order to do that. So when I distribute the x, I have xy minus 4x is equal to 3y. And now you can see my equation has 1, 2, 3 terms in it. So I'm going to move this 3y to the left-hand side, put it with this xy. And then I'm going to move this minus 4x to the right-hand side. Then I'll be able to factor out a y on the left-hand side and solve for y. How do I know to do this? Because I've done it 50,000 times, right? Practice, practice, practice. That's why you do homework. Practice, practice, practice. So let's move the minus 4x to the right-hand side by addition. And we have xy is equal to 3y plus 4x. And now I'm going to subtract the 3y from both sides. So I move the plus 3y on the right-hand side to the left side by subtraction. And I have xy minus 3y is equal to 4x. And now you can see on the left side I got two terms. Each contain y, so I can factor out the y. And I have y times x minus 3 is equal to 4x. And now, right, so the two factors here, y and x minus 3. So solve for y, I divide both sides by the binomial x minus 3. And I have y is equal to 4x over x minus 3. And now step number 4, replace y with f inverse of x, and I have the inverse function. So f inverse of x is equal to 4x over x minus 3. Okay. Now remember the example I put on the board, f of 2 is equal to 5, then f inverse of 5 is equal to 2. So we can test that with these two functions, right? So let's use the number 5, because in the denominator 5 minus 4 is equal to 1. So f of 5 I'll put 5 in for x. I have 3 times 5 over 5 minus 4, which is equal to 15, right? So f of 5 is equal to 15. So f inverse of 15 should equal what? 5, right? So let's put 15 in for x up here and see if that's what we get. So on the right-hand side, we get 4 times 15 over 15 minus 3. 4 times 15 is 60. 15 minus 3 is 12. And 60 divided by 12 is 5. So what goes into f of x comes out of the inverse, and what comes out of f of x goes into the inverse, right? That's the relationship between one-to-one functions and their inverse. Yes, ma'am?
Why did you put 5 in for?
Oh, I always get asked that question. And I did it because the math is easy.
Okay. So it doesn't matter what?
You could use any, right? We're going to talk about the domain and range of these two functions, right? But you know the domain of f of x is all real numbers except for 4. So I could use any number except 4. But I chose 5 just because if I put 5 in for x, I get 5 minus 4, which is equal to 1. I'm lazy. I like doing easy math. Okay. I mean, I could have done, 1/2, fraction 1/2, but I don't want to deal with fractions, just prove a point. Okay. Yeah, I'm lazy. Okay. All right. So I chose easy math. That's why I chose 5. I chose easy math. Okay. All right. So we found the inverse function. Okay. So now we got to state the domain and range of each. Okay. Can I erase this? Yeah. Okay. So let's do the domain of f of x. You just had an exam. You had four functions you had to find the domain for. Can you tell me what the domain is here just by inspection? Yeah. So it's all real numbers except for 4, right? Domain of f of x. X minus 4 can't equal 0, right? Or x can't equal 4. So in interval notation, it's minus infinity to 4 union 4 to infinity, right? I mean, that could have been an exam question. Okay. Well, the domain of f of x, or the range of f inverse, is equal to the domain of f of x, right? So the range of f inverse of x is equal to the domain of f of x. It's the same set of numbers, but it applies to the variable y, right? The range applies to the variable y, okay? So y, in the range of f inverse, y can't equal 4. So we have minus infinity to 4 union 4 infinity. The domain of f of x and the range of f inverse are the same set of numbers, except the domain of f of x, the numbers apply to the variable x. Over here, they apply to the variable y. Okay. So that's f of x's input. This is inverse f of x's output. Okay. All right, how do we find the range of f of x? We find the domain of f inverse, right? What's the domain of f inverse? All real numbers except 3, right? X minus 3 can't equal 0, or x can't equal 3. So we have minus infinity to 3, union 3 to infinity. Okay. So we got the domain of f of x, and that gives us the range of f inverse. And now we have the domain of f inverse, and that gives us the range of f of x, right? The range of f of x is equal to the domain of f inverse. Same set of numbers, except they apply to the variable y. Y can't equal 3. And so in interval notation, we have minus infinity 3 union 3 infinity. So that's a very important relationship between inverse functions and their one-to-one functions. The range of one is equal to the domain of the other. So once you know the domain of the function, you automatically know the range of the other. Okay. All right. Is that clock correct?
Yes.
All right, one more, and then you'll have everything you need to do the homework when I release it this afternoon. Okay. So we're going to find the inverse function for the square root of 2x minus 3. Oh, find the inverse function. For f of x. See, square root. I didn't have f inverse written up here before, did I? Previous example? I hope not. Okay. I think I just wrote it after I erased it. Okay. Now we're going to take a little different approach on this one. Sometimes you have to do things a little differently. Okay. So you should recognize, okay, that f of x is a transformation on the square root function, right? So here's the square root function, right? Y equals square root of x. So if I multiply the right-hand side by square root of 2, I have y is equal to square root of 2 times the square root of x, which is equal to square root of 2x, right? When I multiply the right-hand side by square root of 2, that is a vertical stretch, right? Square root of 2 is greater than 1. So this is a vertical stretch on the square root function. And then when I subtract 3 from both sides, what does that do to the graph of the square root function? Shifts it down, right? So then we have y is equal to square root of 2x minus 3, and that shifts the graph down 3 units. Okay. So the graph of the square root function, starts at the origin and looks like this, right? This is y equals square root of x. So it starts here at the origin. And when I multiply by square root of 2, right, it vertically stretches it, okay? But then when I subtract 3, it shifts the graph down 3 units, right? And so instead of starting here at y equals 0, the graph is going to start where? When I shift the entire graph down 3 units.
0, 3.
It's 0 minus 3, right? Y equals minus 3. So, and for square root of x, you know the domain in inequality notation is x has to be greater than or equal to 0, and the range, right? You can just get that from looking at the graph. And the range, right, starts at y equals 0, and there's no maximum y. And so the range is y is greater than or equal to 0. Okay. But now, in graphing the f of x, right, we got to stretch it by square root of 2 and then subtract 3. And so the graph is going to get shifted down. This point right here where it starts is going to get shifted down here to y equals minus 3. here's the x-axis, and here is -3 on the y-axis, okay? And then the graph, right, looks like that, going up. It's going to cross the x-axis somewhere. But it starts here at the point 0, -3. Okay. So this is the graph of y equals the square root of 2x minus 3. Now the reason I'm showing you this is because when we find the inverse function, we're going to end up with a quadratic. You remember the parabola, right? The squaring function is not 1-to-1. And so our inverse function is going to be half of a parabola, not an entire one. Okay? That's why I'm doing this. Okay? So some problems you got to take a little different approach. Now, by visual inspection, we did this for exam 1, right? 2.1 part 1. You were given a graph, and you had to tell me what's the domain of this function and what's the range of this function, right? So given the graph of this f of x, okay, what's the domain?
0 to infinity.
0 to infinity, right? So the domain and we include 0, right? So in interval notation, the domain of f of x, okay, is 0 to infinity, including 0. Okay? So let me write out the word f of x. Domain of f of x. So remember, the domain is the x coordinates, the range is the y coordinates, right? Is there a minimum y coordinate in this graph?
-3.
Is there a maximum? So the range is -3 to infinity, right? We're actually going to use, remember the range of the inverse equals the domain of f of x, right? And the domain of f inverse is the range of f of x. We're going to use that relationship with the inverse function, stating its domain and range. Okay? All right. So now let's find the inverse function. Now that we know what the graph of f of x looks like, okay? So let's just remind ourselves, this is the graph of f of x equals the square root of 2x minus 3, right? Which is the transformation on square root function. And remember, square root function is one of those functions I said you should be familiar with in section 2.2. There were 5 of them. Square root of x was one of them. All right. So to find f inverse of x, step number 1, replace f of x with y. So we have y is equal to the square root of 2x minus 3. What's the next step? Switch x and y, right? We have x is equal to the square root of 2y minus 3. Step number 3, solve for y. And so in solving for y, right, first thing we do is add 3 to both sides. All right, we've got to isolate the y on one side. So we have x plus 3 is equal to the square root of 2y. What undoes square root? Squaring. So we square the left side, and we square the right side. You see this shaping up to be a quadratic, right? This is a horizontal shift of the squaring function, x squared. So we have x plus 3 squared on the left is equal to 2y on the right. Okay. Now I'm going to switch the two sides to get the y on the left side. And to isolate y on the left side, you can either divide both sides by 2 or multiply both sides by 1/2. I prefer multiplying by 1/2. You can divide by 2 if you want. And so we have y is equal to 1/2 times x plus 3 squared. Okay? And then last step, replace y with inverse function notation. So that's the inverse function. Okay? So remember, the equation well, that's right in the graph. We graph the squaring function at the beginning of class. So when I replace x with x plus 3, what does that do to the graph? Shifts it to the left 3, right? And then when I multiply the right-hand side by 1/2, that's vertical compression, right? So the graph of our inverse function f inverse of x is equal to 1/2 times x plus 3 squared. Okay. Might be inclined to think, right, is the squaring function here shifted to the left 3 units, okay, and then compressed by a factor of 1/2, right, which makes it shorter and fatter. Okay. Well, you can see that it crosses the y-axis. If you put in 0 for x, you get a y-intercept of 9/2. But I'm not concerned about that. The only thing I'm concerned about is the graph. Okay. That can't be the graph of the inverse function because it fails the horizontal line test. Okay. So we calculated the domain and range of f inverse based on what we know about the graph of the square root function. Right? So the domain of f inverse equals the range the domain of f inverse. I'm saying this right and it's wrong. The domain of f inverse of x equals the range of f of x, right? One of two important properties, right? Well, the range of f of x is all real numbers greater than or equal to -3, right? This is y greater than or equal to -3. That same set of numbers is the domain of f inverse. So the domain, right, the range of f of x is all real numbers greater than -3. So the domain of f inverse is all real numbers greater than or equal to -3. Only applied to the variable x, right? So x greater than or equal to -3, that's everything to the right of this point right here on the x-axis, right? So to get the graph of the inverse function, we have to erase the left half of this parabola. This is the graph, right, of our parabola for all real numbers greater than or equal to -3. Okay? That's our domain for the inverse function. So this is the graph of f inverse of x. Okay? And so in interval notation, right, we have -3 to infinity. So we found the domain and range of f of x based on what we knew about the square root function. Okay. So the domain of f of x, right? This is for x. Right, this x greater than or equal to 0. Then the range of f inverse of x you can get from the graph. What's the minimum y coordinate? 0. There's no maximum. And the range of f inverse is equal to the domain of f of x. And the domain of f of x is all real numbers greater than 0. So we have y is greater than or equal to 0. 0 to infinity. So when the square root function makes us do things a little bit differently, because when we solve for the inverse function, we end up with the squaring function, but the a parabola. So it's not the entire parabola, right? In the graph of the inverse function, it's only half of it. Okay. All right. Any questions, ladies and gentlemen? So you now have everything you need to complete the WebAssign homework, which I will release after class. Okay? And it won't be due until you come back from spring break. Okay? But we will have class tomorrow. Okay? So math department never shuts down. Okay? Not even if there's 12 feet of water outside and there's an arc floating down the street. Okay? We never shut down. Okay? So I'll see you tomorrow. Have a good day.